So yesterday I talked about how I'm sort of shifting my feelings about direct DOM access in an Angular application, and I'm, instead of bending over backwards to maintain a dogmatic separation of concerns between the component classes and the component templates, I'm instead embracing some direct DOM access in order to make life easier and the code easier to reason about and easier to maintain. And one such situation that comes up a lot in my single page applications is the need to reset the scroll of an overflow container. So imagine that we have a tabbed container like this one here, and what happens is if I scroll down to the bottom of one tab container, the default behavior is that if I now go to tab 2, the overflow container will remain at the bottom even though the contents change. That's just a natural behavior of the browser itself. But what we'd like to do is when I go to 2, you see that the scroll gets reset to the top of the overflow container. Similarly, if I scroll down here and then go back to 1, you'll see that the scroll here is again reset. And we can, of course, do this as much as we want. So in order to do this, what I'm going to do is reach directly into the document object model, grab the element associated with this overflow container here, and reset it imperatively or explicitly when I switch from one tab to another. So let's take a look at how this works. So here is my tab widgetry in my app component, and you can see here that I have my two tabs. I'm calling show, so this is the first tab and the second tab, and then here is my overflow container, and you can see that here are the two tab bodies inside of it. So essentially what we're doing is when we show tab 1 or tab 2, all I'm doing is updating this selected tab value, and I'm using the ng-switch and ng-switch case directives to swap the content of that overflow container. So what we want to do is look at what actually happens when we call show in order to reset that scroll offset. So if we scroll down here to show, what we can see again is we're just updating the view model of the component in order to change the content of our template. And then we're calling this scroll tab content to top method. The scroll content to top method is reaching into our native DOM element and calling the .scrollTo back to the x and y 0, 0 offset. So essentially this is scrolling that overflow container back to the top left of its scrollability. Now, where do we get this tab content ref? Yesterday I just used the host element and called query selector on it, but today in order to mix it up I wanted to use a view child query and dependency injection of sorts. So if we come up here to our component metadata, we can see that I'm defining the queries that are going to be exposed to this app component, and I'm asking it to use a view child query to find tabs content ref, and then whatever the result of this is going to be injected into my app component as the tabs content ref property. So tabs content ref here becomes a reference, a hashtag reference here in my template. So what this view child is going to do is locate this reference and then return this element ref wrapper for this div or our overflow container. Then of course this is a public property, and what we're using here is the definite assignment assertion for TypeScript to tell TypeScript that we're not going to initialize that property in our constructor. We're going to allow Angular, and we're going to expect Angular to assign that value as the public property outside of the known context. That's what the definite assignment assertion is for. So again, this tabs content ref is an injected element ref based on our template ref that Angular is going to provide for us, which is a wrapper around the native element. And when we want to scroll the container back to the top, we're just taking that element ref, reaching into the native document object model node and calling the native DOM method scrollTo. So what this is going to be doing is tightly coupling our app component to the rendering layer of our application. But again, so what? This is going to make our lives a lot easier, and it's going to make the code easy to reason about and easy to maintain. And if we ever need to break this level of coupling, we can always refactor the code later when and if that ever becomes necessary.